this is Anna. I have a background in Master of Electrical Engineering and years of tutoring experience in physics, math, and circuits. I teach students of all levels, NCEA 1 to 2 and university 4th year. Help students understand tricky concepts and boost their confidence. In today's video, we are going to talk about a very classic NCEA style problem with friction involving. It's a kind of a question that challenges students a lot in exam.
So now let's look at this question together. A block of mass 4 kg is placed on a rough incline of 30 degrees. It is put up the incline with a constant force of 45 Newton. The coefficient of kinetic friction between the block and the surface is 0.3. So now the question is asking you draw a free body diagram, resolve it into components, understand friction, and calculate motion. All right. So now we will focus on the first part, understanding forces and friction, which is the foundation for solving this entire problem. Now let's draw the free body diagram. All right, this is a key skill to solve this kind of problem. So now we draw the incline and then objects. So now we're gonna do the first analysis. So how many force applied on this object based on the question talked about? First one is always, as you know, gravity, you never forgot. And then that's the supporting force from the incline. We call it Fn. And then there's the external force mentioned in the problem. We call it F external, right? And then the last one, which is very important, is the friction, F. So now we notice why the friction is downwards inclined because, as the problem mentioned, the external force was the object upwards inclined. So the friction is always opposite. So that's downwards inclined, which is this red color F. All right. So now we can further we notice from this is the theta, which is incline angle. And then we do the decomposition of force. So we're gonna do the decomposition of the gravity, parallel and perpendicular to the incline. And based on the simple geometry, we can figure out this is also theta. It's always the case for this kind of problem. All right. Well, based on this, now we go back to this question again. So we resolve the weight because the parallel component of the gravity puts the block down the slope, right? You can see this. So we just decompose it. So that's this part of the gravity. We see the down the slope. And the perpendicular component of the gravity determines the friction, which is towards the surface, always this one. So this is a key idea in Newton's law in incline, this kind of problem. So now we come back here, we can conclude the formula now. So the parallel component of the gravity is to the incline, which is mg sine theta based on just now the geometry. And perpendicular component of the gravity to the incline is mg cosine theta. So we substitute the number mentioned in the question here, and then we can get the value very easily. So after that, we can simply get the value here. And then after that, now let's solve the friction part. Okay, all right. So this is always a formula for the friction. So it's a coefficient of friction multiplied the supporting force. So as we can see here, the supporting force is balanced with the perpendicular component of the gravity. So that's why we can simply substitute this perpendicular component we just get here, mg cosine theta, which is 33.9 Newton here. And the coefficient is be given in the question. Then just simply substitute here, then we can get the final answer, which is 10.2 Newton. This is the friction, the problem asking about. So from here we notice how friction decrease if the slope gets deeper. Because when slope gets deeper, that means theta increase, right? And then cosine theta decrease. That's why in this formula we can say this part is decrease. That's why we substitute this supporting force here, which is also equals to the perpendicular component of gravity. Remember we just talked earlier. That's why the friction gonna decrease. This is why understanding the component is so important in solve this kind of problem. That's a key skill you need to grasp in this kind of problem. Okay. So in this last bit, we just analysis regarding the relationship in between the friction and the slope. This is also like a very, very important part. The NCEA always expecting students to know. And this is also the most challenging part, like challenging students a lot in the exam. And by this kind of analysis, we just analysis, that is also the answer to tell the difference in between the merit and excellence.
In the full tutorial session, we would continue to calculate net force and acceleration, showing step-by-step how to solve motion and exam-style problems. Today we focus on understanding forces and friction, the essential foundation. If you want a full worked solution along with exam tips and strategies for NCEA Physics or University STEAM courses, click the link in the description to book your first virtual session with me. We will cover step-by-step problem solving, past paper practice, and boost your confidence quickly. Thanks for watching. Don't forget to like, subscribe, and turn on notification for more STEAM tutorials. I will see you in the next session.